Hi guys, so this is the second video with vectors in geometry. So we've got lots of diagrams here and we're going to need to work out what the vectors are. So definitely have watched the first video where I talk about the basics of it all, and then obviously we can get cracking with this one and hopefully it should make a bit more sense. This one I believe is probably just a little bit easier in the fact that you are just taking a journey to help you find out the resultant vectors. So let's get cracking and see what we can come up with. So the first one here is this diagram here. I have my vector A here and my direction here B, and I have my S to R is 2A. And the question is work out the vector P to S. Notice it's got the arrow going there, which means I start at P and I end up at S. So basically I'm at P and I need to end up at S. So essentially I'm working out what that vector is. Now obviously I can't do that just by looking at it, because most of the time, in fact all the time I would imagine, all these diagrams say that they are not drawn to scale, in which case we rely on knowing the other sides. So like I said at the start, we take a journey. Instead of going from P to S going straight that way, I can go across here, down here and across here, and that's going to help me work out what the vector is. So let's do that. So I've got P to S with my arrow. So I'm going to start off at P and I'm going to go this way. Now the arrow is pointing that way, so that's fine. I can keep A the same, and the arrow is pointing down this way, so that's fine. I can say that that's B, but this time the arrow is pointing in the opposite direction. Now you might remember from the first video, if you want to go the opposite way, you change the sign. So at the minute this is 2A, so to go the opposite direction, I'd say minus 2A. Okay. Once you've written that down, so that bit, that bit, that bit, we just simplify it. And we look at the A's. A, take away 2A is just minus A, and I can't do anything with the B's, so that just stays as plus B. So it's minus A plus B, or of course you could write that as B minus A. It doesn't matter, both are exactly the same. So let's have a look at this one then, when it says work out the vector of SP. So this time I'm going the opposite direction. I'm going from S, this time I'm going to P. So I'm not doing that anymore, I'm now going that way. Okay, from here to here. And again, I don't know what that is, but I do know I can go this way around. So let's do that then. So I'm going with the 2A this time. The arrow is pointing that way. So let's just set this up. S going to P, so I can have 2A, that's fine. But I'm going against B. I want to go that way, but the arrow is pointing this way, so I'm going to change that to a minus B. And exactly the same thing here. I'm going against A, so I need to change that to minus A if I'm going to go in the opposite direction. Little bit of simplifying. 2A minus A is A, and then of course I have the minus B. And if we compare these, A minus B, B, you'll see that obviously one way the sign is minus and then a plus, and then if I flip it the other way around, that becomes a positive and that becomes a negative. You change the sign. So remember when I said about here, that direction is A, that direction is minus A, no different here. That direction was minus A plus B, so I go the opposite direction, we change the signs, which leaves me with A minus B. So it just works even if you've got two variables or more. Okay, let's have a look at the next one here then. So here we have a parallelogram, and what people always forget with parallel lines is that although you've been given this one and this one, if you have parallel lines, you can actually fill in other lines or other vectors on the diagram as well. So what I mean by that is, if this line here is A going in this direction, the parallel line here will also be A going in that direction, and that's actually the first bit here. Work out the vector SR, so S going to R is just that there, A, because it's parallel to that line there. And you're probably already ahead of me. This line here is going to be parallel to this line here, so I can do the same thing and say that that's B going in that direction, same as that. Slight difference here though is that we're asked what P to S is, so P going towards S, so it's going in the opposite direction of this B, So all I do is I change the sign, say it's minus b, and we're done. Second question here. Now I fill this in, we can start having a look and then do the first one, which is p r. So I start at p, I need to end up at r. So essentially I want that, but I don't know how to go from there to there. But I can go this way, or I can go this way. Both give you the same answer. I'm going to go this way, so that's a, because it's going in the same direction, and then minus b, because I'm going in the opposite direction. And if you went the other way, minus b plus a gives you the same answer. And then I've got r and p here. So here I am at r, and I need to get to p, so I need to go that way and that way, or I can go that way and that way. I'm just going to go this way and that way, so that's b, because it's in the same direction, minus a, because it's in the opposite direction. And as you can see, just like with the one over comparing these two, positive a, negative b, positive b, because I went one way and then I went the other way. So if you change direction, you always change the signs, or times it by -1 if you like. Okay, so there's some basic ones. Let's move on. So keeping with the parallel line theme, and this does come up quite often, or I've seen it a few times I should say, as opposed to come up often. I have seen it a few times where we have a regular hexagon and they ask us questions along with vectors. And again, just like with the parallelogram, people forget when you have parallel lines you can label it. So if I have this line here is A, that's also going to be A, that's also going to be A, and that's also going to be A, and if that's B, that's also going to be B, that's also going to be B, and that's also going to be B. So you can straight away label your parallel sides, and that makes it a lot easier. So let's have a look then. I've got A going to C, so I've got loads of different ways I could go about it, but I'm just going to keep it nice and simple and go A, because it's in the same direction, and then B. Easy. C to F, so C is here and F is here, so I need to go the opposite direction, that's A, so if I want to go the opposite direction, that's minus A, and then again another minus A, and simplify that to be minus 2A. So going that way straight across. You can go other routes, you could have gone that way if you wished, but probably that's just the quickest and shortest way. B is here and I need to go to D, so again different ways you can go about it, but I'm going to go this way because they're the ones that I know, that's the route I do know. So B is fine, then I'm going against A, so that's minus A, and then with B again, so plus B, bit of simplifying, 2B minus A, or minus A plus 2B, well, probably better to write it like that because the positive's at the front. E to C, so E to C, obviously you could have gone that way, but I don't know what that is. You could work it out to be fair, but it makes sense just to use the routes that we know, so I could go that way, which is what I'm going to do. So I'm going with A here, I'm going against B, so that's minus B, and then with A, and then a little bit of simplifying, 2A minus B, happy days. And then last but not least, A to D, well that's just nice and simple, B, add B, and simplifies to 2B. Okay, so all you're doing to find the vectors is just going along the routes that you know, just being careful that if you go in the opposite direction, you just make it a negative, and obviously you simplify your answers at the end. Okay, so that's that example. Let's have a look at some more. So what they could also throw in to the mix are midpoints. So in this particular example here, the point M is the midpoint of DC, and DC is this line here. Now I've probably written this a bit naughty actually, that probably shouldn't be written there, that probably should be written there, because it makes it look like that's 6p, but in fact the whole line is 6p. So if that's the midpoint, D to M would be half of that, which would just be 3p, and M to C would again be half, which is 3p. But key thing, the direction stays the same. That's 3p, that's 3p, because 6p was in that direction. Okay, so we're dealt with the first bit of information. Let's have a look and do some more then. So I need to go A to D. So start off at A, go to D. So I've got P in the same direction. I've got 2Q in the same direction. And I'm going in the opposite direction. So minus 6p. And then a bit of simplifying. So that's going to be minus 5p plus 2q. Or again, you might write that as 2q minus 5p just because the positive is at the front. A to M, so doing this vector here. Again, we go the roots that we do know. So I'm going to go P plus 2q. And then just to get to M, I just need to do this journey here. Well, that's 3p, opposite direction, minus 3p. So a little bit of simplifying, minus 2p plus 2q, or again, other way around to make the first bit positive, 2q minus 2p. And the last one for this question here, mb, so m to b. So you could go that way around. Now that you know what AD is, we knew that at the start. So A to D is 2q minus 5p. In fact, let's do that. You could obviously go from this way to that way, which is probably the easiest route, but just to show that you could go this way, I'm going to make it just, show you that does work as well. So minus 3p, and then minus this whole thing, because we're going in the opposite direction. So 2q minus 5p, and then plus p, because that is in the right direction. So a little bit of simplifying, we're going to have minus 3p minus 5p. So you take away a negative, which means you add. So basically doing minus 3 plus 5, which is 2, plus another one, which is 3p. And then I've still got my minus 2q. Of course, let's just double check it going the other way. 3p in the right direction, minus 2q gets you the same. That is why I would definitely do that as opposed to this, because you end up with that double negative and it gets a bit tricky. Always try and go with the flow if you can as much as possible, but it both do work. And again, just highlights that point here of that double negative, so be careful. Okay, here we go. Here's another one then. So I've got my M, which is the midpoint of A and B. And this time I don't know what AB is. Over here we knew what DC was, we knew it was 6p, so it was easy, we just halved it. Here we don't know what it is. So what do we do? And sometimes they do in the exam guide you, it'll help you by part A being this, which I've done here, is you work out what that is. So A to B, so it's going in that direction. So I need to go from A to B, so I know this route, which is minus A, because I'm going against the flow there, and then with the flow here, so plus B. So the whole thing is minus A plus B. So this is the midpoint. This is half of this, so half of minus A plus B, and this again is a half minus A plus B. So it's not as nice as that, but that's life. So we just have to be careful with our fractions. So let's have a look then. A to M, where we just did that, that is going to be half of this. So a half of minus A plus B. Now that will probably be the better way of leaving it, because you've sort of factorised that half out, but equally, you could expand the bracket and say that's minus a half A plus a half B. And you might even want to write that the other way around and say a half B minus a half A to get the positive at the start. All of those absolutely fine. We do tend to factorise it like in the first bit there. And then finally, making it a bit trickier. So we've got M to C. So you could go that way, but that's going against the flow, which means there's lots of negatives and it'd be a pain. So I'm going to go with the flow, which is this bit here, and then obviously going against the flow there. So we're going to have half minus A plus B, and then I'm going against this bit here, so minus B, So I'm going to expand that to be minus a half a plus a half b minus b. And then I can simplify this a bit easier. So the a's will stay the same. And then plus half b, take away b, would just be minus a half b. So technically that's right, but as I said, they do like to factorise them, and that does come in handy when you start dealing with parallel lines, because you start to see scale factors, so it's probably a good idea to factor this again. So I'm going to factorise a half out, which leaves me with minus half on the outside, and then a plus b in brackets. As again, that's fine, that's probably the nicer way of doing it, and I say the practicing that does help when it comes to parallel lines later on. Okie dokie, last page to have a look at then. Midpoint is obviously easy, it's half. So what about when the fraction's something different? So here we go then. Again, here is a parallelogram. So straight away, I know that the whole thing there is A, and I know the whole thing there is B. So that's the first thing to recognise, parallelogram, get those labelled on. And E is the point on the line AB, such that A to E is 1/4 of the whole thing. So all that means is that's 1/4 there, which means E to B must be 3/4 of the whole thing. So if the whole thing is B, and that's 1/4, that's just 1/4 B. And if the whole thing is B, and this bit here between E and B is 3/4, that must just be 3/4 B. So once we've done that, oh hang on a minute, there's more here. F is the point on BC, where B to F is 1/4 of the whole thing. So just like before, if this whole vector from C to B is A, and this is 1/4 of that, that's just going to be 1/4 A, which means what's left must be 3/4 A. Okay, now let's have a look. Let's go from E to A. So E to A, well again, the arrow was flowing this direction, and so that means that way is 1/4 B, so going the other way, we just change the sign, so that'll be minus 1/4 B. C to E, so C here to E, we could go that way, or we could go that way. Either one, doesn't matter. I'm going to go this way, I think, which is A to start off with. The whole thing is A, so I can ignore them for now. Just use the A there. And then I need to go to E. That's against the flow here, so that's minus 3/4 B. And it's as simple as that. And then finally for this one, D to F, so from here to here, you can go this way round, or you can go this way round. Both flow in the right direction, so it actually doesn't matter, so I'm going to go this way. So I've got my B, and then plus 3/4 A, because it's going in the same direction. And that's it, you're done. So don't be afraid to use the fractions here. It does make it a lot easier. Don't try and work in decimals or anything like that. Fractions are probably just that little bit easier. If you had a calculator, it might be an argument for decimals, but definitely fractions for me in this one. They might be nice and tell you what the fraction is, like in this question here. However, they could also do it as a ratio. So if you've watched my ratio video, you know I'm a massive fan of using a table. So that's exactly what I'm going to do here. I've got CD, I've got DA, and that's in the ratio of 1 to 2. And don't forget, we always have a total. So that would give me 3. And I would go back to fractions. As I said, working fractions, it makes it nice and easy. So D is the point on AC, so this line here, such that CD is in the ratio, CD to DA is in the ratio of 1 to 2. So C to D, D to A. So what fraction is this of the total? Well, that's C to D, so that's 1 out of the total, so that's 1/3. And then D to A is 2/3. Okay, so what some people will do is ignore the total and go, oh, that's a half, it must be a midpoint. Be careful, draw a table, that's 1/3, that's 2/3. So that's the first thing to be careful of when dealing with ratio. Okay, let's answer some questions. A to C. So A to C going that direction is Q and then minus P, because we're going against P there. Okay, now you know what AC is, you can now know what CD is, and you know what DA is, because we've already worked out that's a third, so that's just going to be a third of Q minus P, and that's going to be 2/3 of Q minus P. So as soon as you know the whole thing, and you know what fraction it is, you can just do the fraction and then put the whole thing in brackets, and you've worked out that little bit there, which is going to come in handy, because I need to do DA now. So D going to A, of course you could go that direction, but it's just going to be easy to do that bit. But the flow, A to C, was going that way. If I want to go that way, D to A, that's going to be a negative. So it's going to be minus 2/3 Q minus P. So again, you can expand that to be minus 2/3 Q, and then a minus times a minus is a positive 2/3 P, and again you could just switch that round to be 2/3 P minus 2/3 Q, and you might want to factor the 2/3 out. It depends. Sometimes the question will say leave it in a particular way, leave it to try and show that the dB can be written as something like this, in which case obviously you keep playing with it until it works. And I've just realized I put that in the wrong bit. That should have been DA. So let's just cross that out, call that DB, and let's call that DA, because that was D to A, and I'll now do DB in here. So D to B, again you could go that way and down, or you can go this way and this way. I'm going to go this way because it goes with the flow, which is 1/3 Q minus P, and then plus P. So again, if I expand that, that's going to be 1/3 Q minus 1/3 P plus P. So minus 1/3 P plus P will leave me with positive 2/3 P. So I'll have 1/3 Q plus 2/3 P. And you might want to factor 1/3 out, because they've both got 1/3 in them. If you take 1/3 out, you're left with 1/3 and then Q plus 2P, which is much nicer. And again, gets you used to that factorizing, which is going to come in handy in the third video when we talk about parallel and straight lines. So hopefully that helps, guys. Apologies for mixing that up, but hopefully that makes sense. That's DB and that's now DA. Probably a bit easier to read than that, so apologies for that. Hopefully you get the idea. Work in fractions. If it's a ratio, put it into a table to work out what the actual fraction is. Be careful when expanding, be careful with double negatives, and just remember, start with 1 point and plan a route of the routes that you know until you end up at the other point where you need to end up. Okay? Thanks for watching, guys. Hope that helps.